So we're going to talk about atomic structure.
Woo.
What are the three main particles?
Protons, neutrons, electrons.
Protons,
Neutrons and electrons.
Oh,
neutrons,
electron.
and electrons.
Yeah.
Gosh.
Rotation. But no, not.
Are you kidding?
Okay, so make a little chart like that. What's the charge of a proton?
Positive.
Positive.
Positive. We consider it to be a +1. What's the charge of a neutron?
Zero.
0. It's neutral. Hence the negative. Electrons?
-1.
-1.
Heck yeah. Shut up.
What is the mass of a proton?
0. +1.
1 AMU. AMU stands for atomic mass unit. What's the mass of a neutron?
1 AMU.
1 AMU. What's the mass of an electron?
3 AMU.
0.
What?
Why you gotta treat this like that?
Okay, now, do electrons really not weigh anything?
No.
They have a very, very slight mass, but it's so insignificant we consider it not to have one. Do protons and neutrons really weigh the same thing?
Yeah.
Yeah.
No.
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 There's probably a little differentiation.
Neutrons weigh slightly more, but it's so insignificant we call them the same for what we're doing. Okay? Everybody understand that?
Yeah, sure.
Where are protons located?
Center.
In the nucleus.
Where?
Nucleolus.
In the nucleus.
Nucleus.
Where are the neutrons located?
In the nucleus.
In the nucleus. Where are the electrons
In
located?
the shell.
Around
The shell.
Outside the nucleus. There's no such thing as shells.
The electron shell.
No, there's no such thing as a shell.
like shells and cheese.
Okay. Where is most of the mass of the atom located?
In the nucleus.
In the nucleus. Brilliant. All right. Anybody know what the symbol for a proton is?
Plus one. Or that, well,
Plus sign.
yeah.
Make sure that's a lowercase p. If it's an uppercase p, it's phosphorus.
Phosphorus plus.
It's a positive phosphorus. Neutrons are N0. Make sure it's lowercase, otherwise it's nitrogen.
That's just no.
No.
And electrons are lowercase e, the negative sign. If it's uppercase, it would be energy. Questions about that?
Why are they all lower?
If they were uppercasing something different. What are protons and neutrons made up of?
Molecules.
Atoms.
They make up the atom.
They're smaller atoms with
They're
more
made up of
protons.
energy.
They're made of something called quarks.
Quarks. Like dead bodies.
Michael.
Quarks.
Oh, quark.
Quark.
What you're gonna do, Michael? Yes.
Are we writing anything else on this chart?
No.
Is that an A or U?
Q-U-A-R-K-S.
Quark.
And they're held. The quarks are held together by gluons.
Oh, you're just finessing them. These are made up words.
Nope, they're not. Well, the error word's a made up word by somebody.
Yeah.
So that thing was-
These are made up by
Wait, so I can properly call a bugle a bagel?
No.
No.
That's just bait. That's
No,
just bait. That's
bagels.
just you mispronouncing
Bagels was
bacon.
that dude on iCarly,
iCarly
that
with the
giant
snot,
yogurt.
the yogurt.
Yeah,
Anyway.
Why are we...
Okay. Quarks make up protons and neutrons. They're held together by gluons. There's 6 different kinds of quarks. It doesn't matter for y'all today. What makes up electrons?
Nothing.
Energy.
Well,
Close to
nothing's not. It's sort of correct. Electrons are fundamental particles, so you can't get any smaller than that.
They're what?
They're made up by electrons.
Electrons are fundamental particles. You don't get any smaller than that. They don't have constituent pieces.
Fundamental.
Fundamental?
Fundamental.
Fudge.
Right.
Is this video gonna be on the
You
cameras?
put the fun in fundamental.
Oh, I tried to do extensive editing to get Michael's voice out of it. Yes, it will. Alright, questions? Excuse me. Can I erase all this?
How do we know that electrons are fundamental particles?
Because we haven't been able to break them down any further.
Yet.
What does that? You think?
But also, them being a basic particle obeys what's called the Standard Model. You know, there's six quarks. There are 6. What are they called? Leptons. There are 4 gauge bosons. There's 1 scalar boson. That all fits into a nice little model. Yeah.
That fits in a little atom this size.
Okay, moving on. Like, and all the quarks have names like up, down, top, bottom, charm, strange, things like that. But you don't know that. Where am I at? Okay. What is atomic number?
It's the number of.
Number of atoms and particles.
And the valence should.
Yeah, the valence electrons.
No.
It's the positive number. Hey, it was right.
Yeah, that's a lot easier.
The number of protons in an atom. Can any element have more, or excuse me, let me rephrase that. Can 2 elements have the same atomic number?
No.
No. The atomic number is what identifies the element, right?
Yeah.
So it makes it what it is. They go from all the way from 1 to 118.
We're not 119
Well, that's as far as they've made them yet.
You think?
yet.
You think in 40 years we're gonna have? How many more elements do you think we'll have in 40 years?
It's slowed down,
136.
so because it's harder and harder to make them.
I think they're just gonna make it like a super atom, and that's just gonna be it.
All right. What is atomic mass?
Why don't you do that?
The number of protons times the number of neutrons
Not times.
Plus.
minus.
Protons plus neutrons.
I
I don't remember anything about that.
Okay, let's talk about a nuclear symbol now.
What?
This is what's called a nuclear symbol. Okay.
How did you write that?
Mr. Yes.
All right. What's this number down here?
Carbon.
No, no, no. Wait.
Oh.
It's a standard. It's the atomic number. Yes. What's this right here?
It's where it is on the periodic table.
What's the 14 stand for?
Atomic mass.
Atomic mass.
Atomic mass. What's the 4?
The charge.
The charge.
Oh,
And this is just the element symbol.
Hold on. You're going too fast.
It's all.
Did you snap it to a Slim Jim?
Yep.
You can stay on. Can my phone just stay on the floor? Keep the phone out of the pocket.
That's fine.
Just don't take it. It's just on the floor.
You're not on it, so I'm not really caring.
Okay.
You can't control it with your mind, so you're not controlling it from there. It's the iPhone double X.
What about that? My pocket 3 times.
Yeah.
One products.
Hold on, wait.
Let me hold on to it, the desk.
The iPhone. You scoop out your eyeball and it becomes an
Ruined that.
iPhone.
I just want you to know you just ruined that.
Here you go.
Wow.
It's projection onto your glasses.
That would actually be cool.
All right.
That's a good one.
Yeah, you just.
Do you remember those contact
Have you ever
lenses
seen
that
that
can like
episode of
zoom in your
Futurama?
vision?
Anyway. All right. Moving on.
Oh, I want
So, how many protons does this carbon have? Or any carbon, for that matter.
6.
How many protons does this carbon have?
6.
6. How many neutrons does this carbon have?
8.
Correct. How many electrons does it have?
4.
6.
0. 14.
2.
2.
Because it's a +4 charge, so it has to equal out twice.
What he said.
What?
Well, this is.
How
6 minus 2. It's a
Because
positive 4 charge.
You're actually one of the most.
It's a positive 4 charge, so that's the 2 electrons will cancel out the 2
You haven't heard-
protons.
Well, we need Larry.
It's like positive and negative charge.
This is why we need Larry. Goddamn, but-
8 equals G.
He knows the carbon. What?
What? Oh.
Electrons equals the protons minus the charge.
Where's the gasoline?
Negative
In my car.
plus positive E equals carbon.
That'll do.
On
Alright.
paper.
That help you make sense of how that was calculated?
No.
Sure. Wait.
Because to get the electrons, I took protons minus the charge, got me 2. Six minus 4 is just 2. Yes.
Wait, so it's just math?
Yes.
Because 14 minus 6 is 8.
Chemistry, simple math with letters.
Because
Algebra.
Geometry. Chemistry.
that. So if I want to get, so if I've got my mass and my protons, I subtract to get my neutrons.
So can we write that with numbers? Like, so how would that? So 2 equals protons and minus neutrons.
Yeah.
So 2 equals.
Ladies and gentlemen,
Hold on, I'm running right.
Oh, I get it.
No, you don't.
Thank you. Because 6 minus 4 is 2. So that's why it is.
Yeah, we just explained that.
all right, moving on.
I'm nice, don't worry. Wait, right one.
Okay, quiet please. Does anybody know what an isotope is?
Yes.
No.
Not really.
I've heard that word like many times.
Yeah, I've heard the word. I just don't know.
It's a naked.
If you think isosceles.
Something naked.
You're saying naked.
Yeah, you're saying naked.
Naked.
It's a naked atom.
Yeah, it's naked.
It has no shell.
Jade says naked.
What? I don't know about you, but I'm 10%
Okay.
neck.
Elements, or should be atoms of the element that have different atomic masses, or isotopes. So, for example, carbon has 3 main isotopes: carbon 12, carbon 13, and carbon 14.
Why are there 3 different ones?
Because that's how the world works.
Yes,
Are they capital C or lowercase?
capital C. Carbon.
I didn't know there was 5.
Okay, so we always said that the number of protons in the same element always has to be the same, right?
Yes, sir.
So what changes?
Not of new
The atomic mass.
Atomic mass, the number of neutrons. Correct.
The atomic.
All right. So those are all isotopes of carbon. Uranium also has different isotopes.
235. Isn't that the one that explodes?
Yes.
Yeah, I was with you.
These are the most common ones.
Where's your range?
Whoa.
They have different number of neutrons. 238 is the one we're usually most interested in.
What's that?
Okay,
I hate that.
ladies and gentlemen, I need you to quit talking. There's also something called average atomic mass. And it's a calculation of the weighted averages of all these isotopes. And I'll write that out here in a minute so you get this copy down.
No, this isn't as confusing as the first one.
It's because you saw the end instead of the beginning.
Why does the top change but the bottom doesn't?
Because they have different number of neutrons.
Yeah.
Well, why are there 3?
The number of neutrons changes, it's a different element.
Right. Number of protons, you mean.
Yeah.
Wait,
Shut up, Tyler. At least I tried.
Okay. These are, okay, be quiet please. These are all the same element, but they have different number of neutrons. They have the same protons, but different number of neutrons.
Why do they have a different number of neutrons?
Because that's the way it works. Because they're different isotopes. Yes.
So what if you add another neutron to carbon, make it 15?
That's possible, but it's radioactive.
So could you make uranium radioactive by adding them on
Most, I think, I hate to say all, but most isotopes of uranium are radioactive. They're not stable.
Oh, so you can't like take away neutrons and make it like better atoms?
Uranium is at a point which you can't do that. Like, like carbon 14 and 13 are also radioactive, and they decay down to 12, which is normal, and that's the most common one, and so it's stable. It's not radioactive.
So is 14 radioactive?
Yes.
Oh.
What does 14 radioactive carbon do?
I mean, what does it do?
What does it, does it explode?
No. It just all right. Normal. Hey, y'all need to get something straight. Normal radioactive material does nothing but emit radiation. Only in certain circumstances in weapons is it made to explode.
How does it explode?
That's beyond the scope of this class.
They launched protons.
So if I were to rub uranium all over my body, would I grow a third arm?
You're more likely to die.
So you're telling me there's a chance?
There's a chance I may turn into a rabbit right now, but it's not going to happen.
Wait, what? Can you turn me to a rabbit?
What is the
Destroy
odds?
Charlie Kirk's arm.
Yeah.
There's a chance for anything to happen.
Yes.
Like,
Man, chance when I snap my fingers, will clip like a chicken. But you know, I mean,
there's a chance that right now my head can fall off.
Please do.
But that is
Yeah, that's
such.
like a one half.
all of you made Dayton not enough.
50-50 shot.
I can make that happen.
I would take that bet.
All right. So let's talk about average atomic mass.
Just making sure. I don't know what it says though.
It's the weighted average of the masses of the isotopes of an element by relative abundance. What does abundance mean?
How many?
It did.
Like how much there is.
Yeah,
Okay.
sure.
So which isotope of carbon did I say was the most abundant?
That one.
Carbon
12,
12.
because
12.
because it decomposes back to 12.
Yeah. Carbon 12 is the most abundant. Okay. So it's going to make sense that our average atomic mass would be close to 12, right? This is how you calculate average atomic mass. So let's say 98% of all carbon in the universe is carbon 12. 0.5% is carbon 13, and 1.5% is carbon 14. Okay? So in order to, what's that? I'm making that up. I do know this is the most abundant. That's not making the rest up. So in order to calculate my average atomic mass, I take 12 and multiply it times 0.98. Take 13, multiply it times 0.005. I take 14 and multiply it times 0.015. And I get answers.
So you just move the thing.
How do you know what percentage they are? I'm sorry.
He's taking
I just
an
made it up.
estimated guess.
I just made it up. You can look it up.
Hypothesizing.
What even are the numbers from? What is the percentage of?
How much there is in the universe. Like of all the carbon, of all the carbon everywhere, 98% of it is this.
Why are there? I already asked you, but I totally did not understand what you were saying. Of why the number changes.
Why the number changes?
Yes.
Protons.
Because the number of neutrons changes.
But how does that change?
How does it change?
There's different variations.
Yeah, there's different. It's like different breeds of pigs. There's different kinds.
That's gonna
You
be.
really is that?
Yes.
But you understand that, don't you?
Understand. It's a different number.
But why is it? I thought it was just like one certain thing, like one set thing. Like it's,
It's still carbon. It's just it has different weights, different masses.
just so they like the exact same thing. Just
Well, and it happens to be usually when they have different masses, they are become radioactive.
Yeah, like uranium.
It's science, bro. It's gonna be confusing.
You're thinking about it too much. Stop it.
Okay, so
It's gonna hurt in the long run. Stop.
My brain hurts.
So this is 11.76. This was 0.065. And this was
One.
hold on, I did that backwards. Hold on. Oh. 0.21. Then I add all three of these together, and I get 12.035.
Wait, why do we add them?
Because I'm weighted each one by using the percentages. Then I add them all together, and that gives me my total. Gives me my average.
Alrighty then.
This is called a weighted average.
Don't you divide them by 3?
Nope.
No?
Because since I multiply it by the percentages, I don't have to.
Oh, okay.
It's a different way of averaging.
So you're saying I can take how many grades I have and then divide
But
by whatever.
but your grades are all worth the same. Okay? So it's the same way. It's like, so if your test grades and daily grades weren't worth 50-50, say they were 70-30. You take your test average, your daily average. Test average times 0.7, your daily average times 0.3. The average, that would be your average. That's what I'm doing here.
That's actually a lot easier.
Makes a little more sense that way?
Yeah.
Okay.
Oh gosh.
Alright, questions about what I did. We will do more of this later. And we're not done.
Oh, man.
We're done?
Giggity, giggity.
Nope.
Are we not?
Alright,
So-
we're gonna do a little practice here.
Oh, wait, don't erase anything.
Oh my god.
Wait.
Or should I sit over here so it gets you on the tape?
Okay, everybody like stop looking at me, it'd be great.
You know better than that.
Shut up.
Can I ever see that yet?
90% of the class already did it.
Go for it.
Alright, thank you.
90.
Like, I keep seeing you out of like my peripheral.
Do it.
It's peripheral.
How are you gonna do
I
it?
kept seeing him like staring at me. I was like, Charlie.
Alright, quiet please. What you're gonna do, I'm gonna put 4 atomic symbols up here on the board. You're gonna tell me how many protons, neutrons, electrons each one has in your notes. You're gonna work these out.
Wow, lithium.
Wake me up.
Okay, do those.
I'm gonna create an elevator.
Hey, I asked you to talk, I asked you to calculate. Give me protons, neutrons, electrons of all those.
Oh.
Okay.
You're an evil person.
I'll get it, it's not gonna be that fast.
I don't think they'll even do it.
Mr. Gallus, if it was negative, would you charge it? Or would you Yeah, you charge it with your battery pack. Okay, so negatives, you add it to the subtracted negative.
Because you're subtracting the negatives of that, right?
Are they in percentages or just numbers?
Those are, this is just the proton neutron calculator, it's not average on that.
We just have to label which one.
Just, no, you just have to tell me how many you have.
Oh,
Those three parts. I'm not labeling you.
well.
Alright, who wants to do lithium?
What? I'm just not going to write it down.
Tyler,
Oh, gotcha.
you have to get through to it.
You should just do the rest of them as them for us.
No.
Has it paid attention to
What is the next one?
Help me.
Even though I don't have it done.
They can't see you. He's out of screen.
Are we supposed to do
Yeah, that's fine. It's fine. So it has 3 protons, 5 neutrons, and 2 electrons.
Yeah, I messed up on that.
Okay,
Could you do 4, 4, 3?
no. 3 protons.
No.
Okay. 5 neutrons because 8 minus 3 is 5.
Oh, okay, I understand.
Electrons. 3 minus 1 is 2.
Oh, okay, that's simple.
Wow, that
makes it a lot easier.
That's why we're doing it.
Wait, how did we get 2? Oh, 3 minus 1. Oh, okay. Okay.
Wow, you couldn't even make it.
You're trash.
No, that's the truth.
No,
Girls,
he's
no.
recycling.
You missed the trash.
That's a recycling bin?
Everyone has a water fish.
You just don't want to go in the trash.
Out of the frying pan and into the fire.
In the recycling bin.
17.
And the reclaiming them.
Mr. Gaddis. Mr. Gaddis.
Correct.
He didn't go in the bin again.
That's burpees.
No, that's 10 push-ups.
Oh, I want to do this one.
Wait.
All right, Charles.
How did we get the
Charles, you get the E.
Charlie, don't
Okay,
screw
hold on,
this
hold
up.
on, hold on.
Charlie, you screw this up.
Look, you took 16 minus negative 2 is 18. When you subtract a negative, it's, you add, right?
Oh.
Ah!
33 minus 16.
He took the easiest one.
We're not taking the next one.
No.
But you don't like it.
Heard them
We
ones.
got.
Bias, Mr.
Yes, it is.
No, he just doesn't like you.
I did the
Doesn't
first one
even-
right.
doesn't-
Did you?
Oh, yeah,
Yeah.
it's 2 neutrons.
But there's
Nope.
no.
Nope.
Wait, how does it? What? How do we tell the electrons?
Because there's nothing there, so you assume that's 0. So how many would there be?
None.
No. If this number, if I put a 0,
Charlie, what?
if I put a 0 here,
Oh, it doesn't. It's 1.
right.
Ah.
What did you put?
You're special, it's okay. We won't
Yeah.
It's
Right,
okay, Charlie.
Charlie. Y'all, hey, just because the camera's there. Towards the ham.
I was just trying to you need to keep that in the video, that's it.
This is my official entry.
Undo it.
We'll be done showing.
All right. All right, Charlie.
Oh, okay. I was totally kidding. I have
He just stood there staring at the camera.
Everyone was like that.
It looked like you were pondering life.
You got this.
You're gonna see a bright neon flash.
The camera.
We'll
can't
turn down the
handle-
brightness on the camera.
The camera can't handle it. It goes to like 20.
There you go.
this one good.
Huh?
30. No. Hold on.
So 20 hours.
36.
Yes.
Is that one is that right?
What time is it?
Say day.
26.
Say
Five.
day.
So usually
Say
Exactly.
Think of it.
I guess that it was.
Wait, hold
Oh
on.
my god.
All right.
You
I was gonna.
All right, we all good on this?
Yeah.